Welcome everybody, thank you for joining. Grab a notebook, pen or pencil, whatever you want to write with. This is math from the void, math coming at you out of nowhere. Today we have a problem from the 1989 AP Calculus exam. This is from the BC exam, but it is totally approachable by somebody in AB because of the topics. So consider the function defined by f of x equals e to the x times cosine of x. So we have a product of two functions, and we're also given a domain, closed interval. So we can ask questions about absolute maximums or minimums with that kind of thing. In fact, here we go. Part A, find the absolute maximum and minimum values of f of x. If it's a continuous function, it has maximum and minimum values at some point. What are the candidates for that? What possible places could we have a maximum or minimum value? We have the endpoints as potential candidates. So the endpoints are going to be when x equals 0 and when x equals 2 pi. Of course, f of 0, actually it's not going to be 0 this time. F of 0 is just going to be e to the 0 times cosine of 0, which is just 1 times 1. So 1. Now f of 2 pi is going to be much larger because even though cosine of 2 pi is still 1, e to the 2 pi is going to be a much larger value. E to the 2 pi, which is something like e to the 6.28 approximately. Don't need to know exactly what that is in value, but we just know that it's pretty large. The other possibilities, of course, this is unavoidable to not take a derivative. The other possibility are the critical points. So we need the derivative of the function, and I'll take a moment to mention this structure here. When we have e to the x involved in a product, the result is for sure going to have, you can factor e to the x out, and there will be like some stuff inside. You'll see e to the x in both of the terms in the product. So just keep that in mind. Critical points, we need the derivative to be set to 0 or undefined. Product rule is as follows. We take a derivative of the first thing, leave the second thing the same, plus we leave the first thing the same times the derivative of the second thing. So this is going to be derivative of e to the x, pretty easy, and leave cosine of x the same. Plus leave e to the x the same, there you go, and times the derivative of cosine, which is negative sine. So as promised, we can factor out e to the x, and we're left with cosine of x minus sine of x. Now we want to find critical points, so we need this to be 0, but you'll notice that e to the x is never 0. We're only looking at this when cosine of x minus sine of x equals 0. So a couple ways to go about this. It's just solving a basic trig equation. This means cosine x equals sine of x, right, if you add sine of x. But what if I divide both sides by cosine? That's going to give me 1 equals tangent of x. Or if you're really good with your unit circle, you'll know when these are equal, like when they're exactly equal. Should be first and third quadrant, right? They're both root 2 over 2, and here they're both negative root 2 over 2. Same thing for when tangent is equal to 1. So these solutions are the exact same solutions. We get pi over 4, and we get pi plus pi over 4, which is 5 pi over 4. Those are the x values, not my answers, but those are the x values of the critical points. So let's find out what the function values are there. I can pretty much guarantee that e to the 2 pi is going to be the largest, because the largest that cosine could be is 1. And the largest that the e thing could be on this interval is e to the 2 pi. Now, if that didn't make sense, that's okay. I'm just predicting that this is going to be our maximum, because these numbers I'm about to plug in are smaller than 2 pi. So the exponential part you see is going to be less. E to the pi over 4. I don't know exactly what that is, but guess what? It's less than e to the 2 pi times cosine of pi over 4. And I do know what that one is, and guess what? It's less than cosine of 2 pi, because cosine of 2 pi is equal to 1. So these two cannot possibly be larger than our maximum. This would be root 2 over 2 times e to the pi over 4. Again, don't really care what that is. I just know that it's something, it's bigger than 1. It's bigger than e to the 0. but it's not bigger than e to the 2 pi, so really we can just ignore that as being a maximum or a minimum. And then we have f of 5 pi over 4, which is admittedly a little bit larger for the exponential part, but one crucial feature here is that the cosine of 5 pi over 4, this is a negative, and so now we're going to get a minimum. This is going to be negative root 2 over 2 times e to the 5 pi over 4, which is some negative number. It's less than 0, so this is the minimum. So 1 is not the minimum. We're going to have our absolute maximum of e to the 2 pi, and it occurs at x equals 2 pi. Then we're going to have an absolute minimum of negative root 2 over 2 e to the 5 pi over 4 power, and that's going to happen at x equals 5 pi over 4. So those are your absolute max and your absolute minimum for this interval. Okay, not too bad. And if you know what this function looks like, it's a good idea to know what the graph looks like. This is called a bounded function or a dampened function. E to the x normally grows, continuously, like exponentially, of course, like this. Now what's going to happen is it's going to exhibit cosine behavior, so this is more like a boundary curve. And the negative one is also a boundary curve. The function is actually going to do something like this. So it's getting more extreme, I should say, as we go. But it is fluctuating from negative to positive, and that's because of the cosine function fluctuates between negative and positive. So what we're looking at is probably somewhere around like right here-ish. I don't know. Well, e to the 2 pi would actually be once it completes its full cycle. So we're literally looking from here to here, from 0 to 2 pi. So see how it goes. Starts at 1. Then it hits 0 here. We found that spot. And then it goes to negative. That's where our minimum is at. So this is going to be located at, what was that? 5 pi over 4. And then this is at 2 pi. Okay, just to give you an idea of what it looks like, because the next question is about where it's increasing, and we can see that it's increasing from this minimum all the way up there. So let's take a nicer look at this derivative to understand when it's increasing, right? Because that means f prime is greater than 0. So let's use a chart. We already have the derivative. It's e to the x times cosine minus sine. And it's really simple to determine when that's going to be positive or negative. If the sine value is bigger than the cosine, it's going to be negative. If cosine is bigger, then it's going to be positive. Right? So let's put that on a chart. E to the x is always positive. Cos x minus sine x. We already know when that equals 0. It has two zeros. That's when the tangent is equal to 1. In other words, pi over 4 and 5 pi over 4. Other than that, e is always positive. These are 0 here, so let's just think about it. If you think about 0, cosine of 0 minus sine of 0, that's 1 minus 0, that's positive. Then it goes negative, then it goes positive. So overall, f prime is positive, then it's 0, then it's negative, then it's 0, then it's positive. That means that this function is increasing, f of x increasing, on the interval from 0 to pi on 4. But also union 5 pi over 4 until 2 pi. I guess we can say, yeah, there we go. And that's our answer for part B. We already took the derivative, we just have to analyze it. Ooh, and then part C wants us to find the x-coordinate only of each point of inflection. So this means f double prime, not just equals 0. I don't want to see that it just equals 0. It changes sign. That's really what happens that's unique here. So let's find what f double prime is. It's going to be another product rule. F double prime, we're going to do the derivative of the first piece times the regular second piece plus regular first piece times the derivative of the second piece. So e to the x, and then the cosine minus sine stays the same, plus the original function, e to the x. Remember, e is its own derivative. It's very nice to work with. Times the derivative of this, which is negative sine of x minus cosine of x. And then, as promised, if there's e to the x involved in the product, we can factor out e to the x. That's going to leave us with cosine minus sine minus sine minus cosine. So the cosines are actually going to cancel, and we're going to have negative 2 sine of x. Let's analyze this on a chart. Of course, e to the x is never anything but positive. It's always positive. Be like e to the x to you and your friends in your social circles. Just always be positive. And then we have the other factor, negative 2 sine of x, which has some zeros. They're pretty obvious zeros, right? When does this equal 0? At the whole pi. So at x equals 0, at x equals pi, at x equals 2 pi. And we know what sine does. It's positive first, then it goes 0, then it goes negative. So the overall second derivative, it does change. It changes right there at x equals pi. Let's see. F double prime has point of inflection at x equals pi. Oh, whoa. Sorry. F has a point of inflection at x equals pi because f prime changes sign there. The wrong sign. Whoops, I went back too many steps. Changes sign at x equals pi. Doesn't matter if it goes positive to negative or negative to positive. It just matters that it changes sign. That's your justification. Okay, so we found where the graph has a point of inflection. If I had to guess the breakdown of points, it would actually be rather hefty on this one, probably 3 and 3 and 3 for a total of 9 points. If I had to guess. It's also possible that this is like a 3-4-2 situation or a 4-3-2, honestly, because there's kind of a lot more work to do on part A. So I might score it something like that. Or maybe just 3s all across the board. So I hope you followed along. If you need to rewatch the video, you can pause it, slow it down, speed it up, do whatever you need to do. Just make sure that you know these skills very well. You can see how much pre-calculus plays into these calculus problems. I mean, this is on the BC exam. This would have been like a breath of fresh air to somebody on the BC exam. Like, whew, they're only asking me about maximums and minimums. That's it. And points of inflection. That's really it. Okay. That does it for our time in the void today. Catch you next time.